All right, so as we sit and as we look at your next two learning targets, I can describe the relationship between potential and kinetic energy, and I can compare the kinetic and potential energy of different objects at varying positions. Okay, you've showed me in your pre-assessment that you had a fairly good understanding, or you thought that you had a fairly good understanding of potential and kinetic energy. And as we've kind of started to explore, you guys have shown me that. We're going to take it a step above that, and we're going to have to be doing some calculations. You're going to be calculating the amount of energy that's actually in it. So yeah, a lot of you did a really good job with the bell ringer at telling me, okay, at the top of the roller coaster, it's potential energy, and when it starts moving, it's kinetic energy. But we're going to start calculating energy and how much energy something truly has. Okay, so we're taking it a step further. All right, so let's start with kinetic energy. And what can you tell me about kinetic? What is kinetic energy? Savannah, what is kinetic energy?
Motion, moving.
All right, it's motion, it's moving. So as we go ahead and we fill in our notes, remember when I underline, you know that it goes somewhere in your notes. Okay, so kinetic energy is energy of motion. And as you explored in your homework and your workbook pages, there are two main things that affect kinetic energy. Does anybody remember what those two things are? If you have your workbook pages, it was on page 281. Elise, do you remember what they were?
Mass and velocity.
Mass and velocity, very good. So as you look at that next bullet in your notes, what's another word for velocity? Speed, good. So I'm going to put speed in parentheses there. So we've got directly depends on the velocity or the speed and the mass of that object. Okay, so you put 2 bullets there. So what do you think? The greater the mass of something, what do you think about how does that relate to its energy? How do you think that relates? Let me give you an example. Let's say that we have a bowling ball and we have a golf ball. And I'm sitting on one side of Anna, sitting over here, and I push them at Anna. Okay, and I'm able to make sure that they're at the same speed. Which one do you think is going to have greater energy, the bowling ball or the golf ball? Which one do you think is going to have greater energy? Chris? The bowling ball. Why?
Because it has more mass.
Because it has more mass. Okay. Now I have 2 bowling balls. Okay, and I'm able to control, and I'm going to do one at 60 miles per hour at Anna and one at 10 miles per hour at Anna. Which one's going to have the greater kinetic energy? The one going at 60 miles per hour at Anna or 10 miles per hour, Sydney?
The one going at 60 miles an hour.
Because it has the more...
Speed.
It has more speed. So as we look at your next sentence in your notes, let's sum up what we just said. Okay? We said the greater the velocity and mass of an object, the more kinetic energy it has. Okay, and so when we look at actually calculating and figuring out the kinetic energy, I've got the formula up there and I want you to fill that in. So in your notes it says the formula for determining kinetic energy is, and I want you to copy this down, kinetic energy equals half times mass times velocity squared. So half times mass times velocity squared. So we're really seeing the relationship between math and science. We've got to have that, it works hand in hand. Okay? All right, so we've got an example. We've got example 1 in your notes. Okay, somebody read for me example 1. All right, Rusty, go ahead and read example 1 for me.
A ball weighs 0.3 kilograms and is moving at 10 miles
It's meters.
That's
fine.
10 meters
Per second.
Per second. What is the kinetic energy?
All right, so we're going to do this one together, and I'm going to do it in the top right-hand corner of the PowerPoint, so as you're following along, that's where it is. So go ahead and let's write our formula. We got kinetic energy equals half mass times velocity squared. So that's the original formula that we're using. So kinetic energy equals half, that light's in the way, isn't it? Mass times velocity squared. All right, so in my example, what's the mass? What's the mass of my ball? Caitlin? It's 0.3 kilograms, so we're going to plug it in here and say 0.3. All right, and so 0.3, and then what's the velocity of our ball in the problem? What is our velocity? What is the velocity, Joe? 10 meters per second, so we're going to do 10 squared. All right, so you're following along with me. All right, then all we have to do is we have to use our math, and that's why I told you might want to bring your calculator this week, okay? So as we plug that into the calculator, 10 squared, what does 10 squared mean? What does that mean math-wise? What are you going to do? 10 squared. Ellie? 10 times 10. All right, so plug it into the calculator. We got 1/2, or we got 0.5 times 0.3, or 3/10 times 5/10 is 15/10. And then 15/10 times 10 times 10 is 10 times 10 is 100. So 0.15 times 100 is what? All right, now let's go back to our vocabulary. And you know you got a vocabulary quiz coming along. What is energy measured in what unit? We can't leave our units out. Savannah? In joules. So make sure you write joules. And you can write the J. I just chose to write it out that time. All right. Okay, so I'm going to give you about 2 minutes, and I want you to look at example 2. While you look at example 2, I will tell you, those of you that finished that early, I'm going to challenge you to look at the challenge problem. Those of you that are in algebra, you can probably handle it. I want you to try your best, and I want you to challenge yourself. So I'm going to put about 2-3 minutes on the clock. I want everybody doing example 2. And then everybody needs to at least read example 3. Those of you that are in algebra, I want you giving it a shot. Okay? All right, so I'm going to pause this, and you're going to have 3 minutes. All right, we're going to talk before we go over the examples. So I want attention up on the board. Put your pencils down. We'll come back to them. Okay, now that you've had some time to think about it, let's talk about mass and velocity. Which one do you think has a bigger impact? Based on that formula that you have, which one do you think has a bigger impact? Do you think mass has a bigger impact? Or do you think velocity has a bigger impact? I want you to put a thumbs up if you think mass has a bigger impact. I want you to put a thumbs down if you think velocity has a bigger impact. All right, I see. Okay. All right, so let's look and let's put your hands down. We'll go over what the right answer is. But as we look, so we've got that example that we had just gone over with the ball. And let's just play with that. And instead of having 0.3 kilograms, if we double the mass, so if we double it, instead of 0.3, we have 0.6. What do you notice happens to the energy? We go from 15 to 30. So what happens to the energy? It doubles. So with mass, when we double it, it doubles the energy. Okay? Now down here, let's double the velocity. So instead of 10 meters per second, we get 20 meters per second. And instead of 15 joules, then we have how many? We have 60. So what happens to the energy when we double velocity? It quadruples. Okay, so which one has the bigger impact, mass or velocity? Velocity. And you can see that right here. We doubled both. And you can see when we double velocity, it quadruples it, whereas when we double mass, it just doubles it. Okay, so let's look at your example 2 that you've got in front of you. So example 2. I was walking around and I was trying to make sure that you had it set up correctly. So when you've got kinetic energy, okay, you should have set it up 1/2 times 1200 times what? 15 squared. And that was the biggest thing I was seeing is you're forgetting about your square. What's 15 squared? What's 15 times 15, Chris? 225. So I'm just going to write that down there. Okay, so we got 225 times 1200 times, and I saw some of you writing 1/2 as a decimal. Is that okay?
Yeah.
Yeah, okay. All right, who did the math? Who figured it out? As long as you set it up correctly there. Savannah, what'd you get?
1350 joules.
Close. I think you're missing a 0 or place value. Colton, what'd you get?
135,000.
Anybody else get 135,000 joules? Yeah, okay. All right, Savannah, you just might have left off a 0 there or something, okay? All right, so 135,000, and thank you for including the units, joules. All right, for those of you, my algebra students, let's talk about number 3. If you are not an algebra student, I want you to be writing down the notes, okay, and copying it down as said. So, all right, let's set it up. Caitlin, what are we looking for in number 3? How fast it's moving. So we're looking for the velocity, okay? So when we set it up, how are we going to set it up to begin with? What are we going to look like there, Abby?
120 equals 1/2 times 60. Is that right?
And then we got our what?
Squared.
V squared. All right, so originally when we set that up, that's how we set it up, okay? You are copying this down. All right, so 120 equals, what's 1/2 of 60?
30.
1/2 of 60 is 30, so I got 120 equals 30 V squared. All right, we know in algebra we want to get the variable by itself. In this case, I kept V up there so I knew it was velocity. Okay, so how do I get my V by itself? What's the first thing I need to do? Elise? Not the 1/2. If you see, I already got the 1/2. I multiplied 1/2 times 60 to get 30. So I divide the 30. So I'm going to divide both sides by 30. 120 divided by 30 is what? 4. So I'm going to have 4 equals V squared. Is my V by itself? What's still there? The squared. So what undoes a square? What undoes that, Savannah? A square root. So if I take the square root of this and I take the square root of that, what's the square root of 4? 2. So my velocity is 2
meters per second.
Meters per second. Don't forget your unit. So here is the answer. Any questions for those of you that understand the challenge and knew what we were doing there? Anna?
I did that differently. I multiplied, no. I divided it by 1/2. No.
All right, so if you divided it by 1/2, it's the same thing as multiplying it by 2. Which I had a student earlier that did that. So yours would have looked like, you still would have gotten the same answer. Uh-oh. Okay, so you still, I'm going to do it real quick, Anna, so watch right here.
I accidentally divided by 2.
Yeah, so if you divide it by 2, it's really the same thing as multiplying by 2. You still would have gotten the same answer had you done the math right, okay? Because I had a student earlier that did that. All right, you guys ready for me to quiz you on some kinetic energy? Yeah. All right, grab your clickers. Let's see how well you've been listening today. Okay, keep your notes handy. So my first question, all 4 objects are rolling at the same speed. Which would have the most kinetic energy? You don't have to hit the silver button in the clicker. You just have to hit A for marble, B for tennis ball, C for bowling ball, or D for golf ball. And this isn't a game like we usually play with the clickers. I'm just pulling you, so answer it honestly. Just grab one pen for now, for today.
Put 3 instead of C.
It's okay. As long. All right, if you see the number come up, that's okay. Just know these 2, 3, 4. All right, so I've got, let me see, how many of you I got in here today? 1, 2, 3. I should have 29. All right. I'll give you about 30 more seconds to go ahead and answer your question. I'm waiting on 2 more of you. Is anybody else having trouble with their clicker? All right, I'm waiting on 1 more. All right, everybody answered? I think I did my math wrong. All right, final answers. Let's see how you did. All right, good. 82% of you said bowling ball. Bowling ball is correct. For the 18% that thought marble and tennis ball, somebody explain to us why bowling ball is the correct answer. Alex L., go ahead and explain it to us. Okay, the bowling ball has the most mass out of those. All right, next one. All of the following are traveling at the same speed. Which will have the most kinetic energy? A bicycle, a school bus, a minivan, or a Camry? A Camry is like a normal size car, for lack of better. Okay? It's a regular car. Okay? All right. I need final answers in about 15 seconds here. Final answers. Good shit. As long as you find it, hit it again. You see that? You're good. All right. Final answers. All right, good. 82% of you said school bus. Why is school bus the correct answer? Ben, why is school bus the correct answer?
Because it can go really fast.
But they're all going the same speed, honey. They're all going the same speed. So what do you know about the school bus versus all the others? Okay, listen. I'm coming back to you. Brendan, what do you know about the school bus? It has more mass. Ben, what's so special about the school bus?
It has more mass.
It has more mass than all the others. Okay? All right, next question. All of the following airplanes have the same mass. Which airplane has the most kinetic energy? The airplane traveling at 200 miles per hour, the airplane traveling at 100 miles per hour, the airplane traveling at 50 miles per hour or the airplane traveling at 300 miles per hour? So we're flipping the tables. We're not talking, all the mass is the same now. The speed happens to be different. I'm waiting on one more person to answer. All right, I need final answers. There we go. All right. All right, 82% again said D. That is the right answer. Somebody explain to me why D is the correct answer. Kenzie, go ahead. Explain why D is the correct answer.
Because that airplane has the most speed.
It has the most speed, so it has the most energy. All right.
Why is always 18% getting?
All right, next question. A soccer ball with a mass of 0.44 kilograms is kicked at a velocity of 10 meters per second. What is the ball's kinetic energy? So you're going to have to do some math. If you have a calculator, share it if somebody needs it. All right, I'm waiting for, it looks like 6 of you. I'm going to give you about 15 more seconds to make your best effort. All right, final answers in 5, 4, 3, 2, 1. Okay, so it looks like we still need some work on this. 64% of you did get it correct. Okay, if you were not the 64% that didn't get it correct, listen carefully. Okay, we're doing kinetic energy equals 1/2 times mass times velocity squared. So what's 10 times 10? 100 times 0.44 times 0.5, which is the same thing. All right, so we get 0.22 times 100, which equals 22 joules. Okay, so that's telling me that that's something we're going to have to continue to work on as a class, okay? Good thing the test isn't today, right? All right. Let's talk a little bit about potential energy. We're looking probably not until after fall break, okay? We might have a little self-check on Thursday, but all right. Potential energy. What can you tell me about potential energy? As we look at that second half of that learning target, I can describe the relationship between potential and kinetic energy, and I can compare them at different varying positions. What do you think potential energy is? What do we remember that as? Rusty?
Stored energy.
Stored energy. Very good. Okay, so potential energy is stored energy. So as I underline it, you know that you're filling it in. Okay, and it's energy that's stored by doing work against a force. And you'll notice there's a second blank in there. Miss Wilson added it in there on accident, so you can cross that second blank out. Okay, energy is stored by doing work against a force. So it's stored. We talked earlier about potential energy in a roller coaster being where? At the top of the hill. Okay? So that's your potential energy. Your book sitting on your table, does that have some stored energy? Yeah. Okay, they're sitting there. Work is being done against a force, so that table's holding it up. Okay? All right, now there are 4 types of potential energy. 4 types. The first one we're going to talk about, and the first one you're going to fill in your notes there, is going to be elastic potential energy. So number 1 in your notes, I should switch my color, is elastic potential energy. And notice it's that key of, it says stretching an object. So what's your first thought when you think about stretching an object? Kylie? A rubber band. So we can brainstorm some examples. What else you got? Okay. Chris, what do you have?
Underwear.
What did you say? Underwear. So the elastic band in the underwear, okay. Works.
Good job, CJ.
Rusty?
Taffy, because taffy can stretch out into different shapes.
All right, taffy.
Silly putty.
Silly putty. What about a slingshot? Does that have elastic potential energy in it?
Yes.
Okay, I got 2 more I'm going to add, and I just want you to have a couple. Okay, the 2 that I had in my notes, a slinky, okay, and a pogo stick. A pogo stick you might not think about. What happens with the pogo stick? Are you stretching it? Okay, there's compression though. Okay, and so when you jump on it, you build that compression, and then when you go up, it stretches, and then it comes back down and compresses. So a pogo stick is also an example of elastic potential energy. Okay, so there's your first example, or first type of potential energy. Second, number 2. Okay, number 2 is going to be chemical potential energy. All right, so number 2, chemical potential energy. What would be an example? You got a picture of an example up there, Kenzie?
Well, I said pizza.
Pizza, so we're being more specific. Pizza,
Beans.
beans, food.
Chocolate.
Okay, let's get off the food train there. What else would be a chemical potential energy? Thinking about my car sitting in the parking lot. What about my car?
Oil.
Anna? The gasoline. Okay, Sydney?
You.
Okay, good.
Electricity.
All right. And so now as you look at your notes, you should have the whole front side filled in. Is that correct?
Yes.
Okay.
Oh,
So,
except for electrical.
all right. So tomorrow, when we come in, we're going to wrap up potential energy. We're going to start a lab exploring the relationship between the two. Okay? All right.